When a massive skyscraper goes up in your city, there is a fundamental expectation that the architects actually have a blueprint.
Right, yeah.
You expect that someone, somewhere, knows exactly what steel went into the beams, what concrete was poured into the foundation, and that all of those raw materials meet a rigorous safety standard.
I mean, it's a physical necessity. You want the absolute certainty that the building isn't going to just, suddenly collapse under pressure because some contractor decided to cut corners on the rebar.
Exactly.
It really just comes down to establishing trust through total transparency.
But then you step into the world of modern artificial intelligence, and suddenly those blueprints completely vanish.
Oh, completely. They're just gone.
Right. We are essentially living and working inside these digital skyscrapers built by massive tech monopolies, and in many cases, they absolutely refuse to tell us what materials they used to build them. We just don't know what data they scraped to pour the foundation.
It really is the ultimate black box. You have these incredibly powerful tools generating code or, writing legal briefs or diagnosing medical symptoms.
Yeah.
But you have no idea what information they ingested to learn those skills. If it makes a critical mistake, you can't trace it back to the source.
Which brings us to today's deep dive.
Yeah.
We have a brand new pre-training report in our hands for a foundational model called Soofi S30B A3B. So, okay, let's unpack this. What we're looking at is a sovereign, truly open source AI from Europe that is punching just wildly above its weight class.
It really is.
It speaks flawless English and German, and it does it while running incredibly cheaply.
And this matters for you because if you have ever felt frustrated by AI models that are hidden in those black boxes we talked about, or models that completely fall apart when you ask them to speak a non-English language,
Yes.
or even models that are just entirely too expensive for a normal business to run on a massive scale.
Yeah.
Well, Soofi S is essentially the blueprint for how to solve all three of those problems at once.
So to really appreciate the magnitude of the solution they've built here, we need to clearly define the battlefield first. We have to understand why those three specific gaps exist in the current open-weight AI landscape, starting with this concept of open washing.
Right. Yeah, open washing is probably one of the most deceptive trends in the industry right now. You see companies releasing the weights of their models, which just means they let you download the finished compiled AI so you can run it on your own computer, and they proudly market it as open source.
But it's not actually open source, is it? It's like giving someone a fully baked cake,
Yeah.
but absolutely refusing to give them the recipe.
Yes.
Sure, I can eat the cake, but I have no idea if you put something in there I'm allergic to,
Yeah.
and I certainly can't bake it myself to see how you made it.
That is precisely it. They hide their training data, their preparation recipes, and the thousands of engineering decisions that went into making the model.
Right.
They get the good PR of being open, but it's closed in substance. You can't audit it for bias, and scientists can't reproduce the results to check their work.
Wow. Okay, then we have the second gap, which is the language deficit. Now, I see headlines all the time about models that speak 90 different languages. So why is there a deficit?
Because speaking 90 languages and actually reasoning deeply in them are two very different things.
Oh, yeah.
The industry tends to produce these general-purpose multilingual models, but they spread their capacity so incredibly thin across dozens of languages that major economic and scientific languages, like German, for instance, are left severely underrepresented in the training data.
So they basically end up knowing a little bit of everything, but mastering absolutely nothing outside of English. Like if you ask it to translate a menu, it does fine. But if you ask it to analyze a really complex German tax document, it just completely hallucinates.
Exactly. And that brings us to the third gap, which hits businesses right in the wallet, and that's deployment cost.
Right.
When you deploy a model at scale, the cost isn't really driven by how many parameters the model has sitting on a hard drive. It's driven by memory bandwidth. Specifically, a massive bottleneck called the key value, or KV, cache.
Okay, I want to make sure I'm fully wrapping my head around this KV cache problem, because this is where a lot of dense AI models just seem to break down.
Yeah, they do.
So imagine you were reading a massive 100,000-word book.
Mm-hmm.
But the rules of this book dictate that for every single new word you read, you are forced to reread all 100,000 previous words just to understand the context of that one new word.
That sounds exhausting.
Right, but that's essentially what these dense models are doing with their KV cache when they generate text.
Right. That's a brilliant way to visualize the inefficiency.
Yeah.
Yes. Traditional models use something called attention mechanisms.
Okay.
Every time they spit out a new word or token, they have to mathematically look back at the entire history of the conversation to decide what comes next. They store that history in the KV cache.
Right.
So as your prompt grows from a paragraph to tens of thousands of words, that cache becomes massive. The computer spends all its time and memory just juggling that massive backlog, and the model slows to an absolute crawl.
But wait, so if that constant rereading is the problem, how do you actually fix it without making the AI lose its train of thought? Like, if it stops looking back at the context, doesn't it just become a goldfish with a 3-second memory?
Well, what's fascinating here is how Soofi S answers that exact dilemma. It targets all three of these gaps simultaneously.
Oh, really?
Yeah. It is radically transparent to fix the open washing. It is deeply bilingual instead of just shallowly multilingual. And to fix your book reading problem, it uses a radical new hybrid architecture under the hood.
Okay, let's pop the hood on that architecture, because this is where the engineering gets a bit bizarre, but brilliant.
It does.
The model's full name is Soofi S30B A3B. Now, the 30B makes sense. It has roughly 30 billion parameters in total. But the A3B is kind of the magic trick here.
Right. It only activates 3.2 billion parameters per token during a forward pass.
Meaning it's a massive model, but it only uses about 10% of its brain at any given millisecond. It's like, think of it like hiring a massive corporation with 30,000 employees. But when a specific email comes in from a client, you don't make all 30,000 employees read it and draft a response.
No, that would be chaos.
Right. A router looks at the email, realizes it's about tax law, and assigns only the 3,000 top tax experts in the building to answer it. You get the brainpower of a mega corporation, but the payroll of a startup.
That is the essence of the mixture of experts, or MoE design. But the Soofi team didn't stop there. They combined those experts with a completely different kind of technology called Mamba-2 to solve your book reading problem.
Okay, Mamba-2. That sounds like a roller coaster. Break that down for us without the computer science degree.
Sure. So to stick with your book analogy, instead of rereading all 100,000 words every time, Mamba-2 acts more like a running tally in a notebook.
Okay.
Imagine you are keeping track of your budget. Instead of pulling out every single receipt from the last 5 years to calculate your current balance.
Which is what the KV cache does.
Oh, exactly. Instead of doing that, you just look at the single updated total at the bottom of your ledger. Mamba-2 condenses the context into a fixed-size recurrent state that just updates as it goes. It basically has no massive cache.
So it doesn't need to hoard all that past data.
Not at all. They adopted a reference architecture called Nemotron 3 Nano, which has 52 layers in total.
Okay.
23 of those layers use Mamba-2's running tally system. Another 23 are those sparse mixture of expert layers we just talked about, and only a tiny fraction, just 6 layers, use grouped query attention, which is the traditional memory system that looks backward and requires that heavy KV cache.
So by stripping out the traditional memory almost entirely and replacing it with this running tally, the memory footprint just flatlines.
It stays near constant even as you feed it massive documents, and the results in the paper are absolutely staggering.
Let's hear 'em.
Out of 40,000 token context, which is roughly the size of a short novel, Soofi S processes over 4.82 thousand tokens per second on a single GPU. To put that in perspective, that is 9.2 times faster than a dense model of a similar size, like the Mistral 314B.
Over 9 times faster. And it all fits on one standard piece of hardware. But that raises a big question for me.
Sure.
If this team is so smart, why did they use an off-the-shelf blueprint like Nemotron 3? Like, why not invent their own brand new engine entirely from scratch just to show off?
Well, for two highly practical reasons. The first is deployability. When a new AI architecture drops, it often takes months for software engineers to figure out how to support it.
Oh, that makes sense.
But because Nemotron 3 is already a known quantity, it works immediately on standard server software like VLLM that companies already use. Anyone can download Soofi S today and run it at full speed without writing custom code.
Yeah, that makes total sense for adoption. Just make it easy to use.
But the second reason is even more important for the science, and that's control. By using an existing, well-documented architecture, they basically turn the original Nemotron model into a scientific control group.
I see.
If they had changed the engine and the fuel at the same time, we wouldn't know what caused the improvements. By keeping the engine the same, they proved to the world that it is their specific data recipe that makes Soofi S so special, not just the code.
So the engine is standard, but the fuel is exotic. Let's kind of dig into that data diet, because feeding this bilingual beast was a massive undertaking. I mean, they didn't just dump all the data in at once and hit blend.
Oh, not at all. They fed it an incomprehensible 27 trillion tokens, which is just massive volumes of text across a meticulously planned three-phase schedule known as warm-up stable decay.
Let's walk through those phases, starting with phase 1. This is the diverse pre-training part of the schedule where the model does the bulk of its eating, right?
Correct. Phase 1 is all about volume and building a broad foundation. The model consumes about 20 trillion tokens here.
20 trillion.
Yeah. It's absorbing general knowledge, pulling heavily from high-quality web data, computer code, and math. But what is truly radical is how they handled the German language. In standard multilingual models, German is usually just a tiny afterthought. Here, it is intentionally bumped up to 7.2% of the entire mix from day one.
Just to give a sense of scale for you listening, the original multilingual blueprint they were comparing against only had 5% set aside for all non-English languages combined. So they're absolutely force-feeding this thing high-quality German right out of the gate.
Yes, exactly. And once that broad foundation is built, they move to phase 2, which is the high-quality annealing phase. This is the decay portion of the schedule.
Now, annealing is a metallurgy term, isn't it?
Yeah.
Like when you heat metal and cool it slowly to remove internal stresses and make it stronger. How does that translate to an AI's brain?
It's a great parallel. In AI training, they do this by dropping the learning rate. Imagine a college student cramming broad, disjointed concepts all semester long. That's phase 1. Then, right before the final exam, they slow down. They stop reading the entire textbook and hyper-focus entirely on a few highly complex, specific practice problems to solidify their understanding. Dropping the learning rate tells the AI to stop making wild, sweeping changes to its brain and start carefully consolidating what it knows.
And what kind of data are they feeding it during this hyper-focused phase 2?
Only the elite stuff. They drop all the lower-tier internet data. The model reads about 6.58 trillion tokens, but the focus shifts heavily to STEM subjects, deep reasoning tasks, and supervised fine-tuning or SFT data.
Oh, wow.
And the German content, it basically doubles. German makes up 15.32% of this elite annealing pool.
And then they wrap it up with phase 3, stretching the model's context window to 1 million tokens using bucketed length so it can handle huge documents.
Right.
But here's where it gets really interesting. So wait, if you force a model to eat 3 times as much German data as it normally would, shouldn't it inherently get worse at English? We just established this model only activates 3.2 billion parameters at a time. There is finite space in that active brain.
Yeah, it feels like a zero-sum game.
Exactly.
That is exactly the assumption most engineers have. It's a phenomenon called catastrophic forgetting, the idea that learning a new skill overwrites an old one. But the benchmark testing in the paper completely shatters that assumption. Because they had that baseline control group we talked about, we can see exactly what the heavy German diet did. Against the exact same Nematron 3 baseline, Soofi S improved its German language proficiency, the GLPDE benchmark, by a massive 15.1 points.
Okay, so got incredibly smart in German, but what was the cost to its English?
There was no cost. In fact, its aggregate score in English actually improved by 1.8 points.
Wait.
Yeah. But even more impressively, they tested it on something called the GPQA Diamond benchmark. This is a set of the hardest graduate-level science questions available, like a test designed specifically to stump human PhDs.
Wow.
Soofi S jumped 9.6 points on that benchmark. It also leads open-source models on complex coding tasks in German, hitting 84.2% on the MBPPD benchmark.
How is that possible? How does shoving more German into the model make it better at English science questions?
Well, it turns out if you curate the data carefully enough, reasoning isn't bound by syntax. Teaching a model to execute deep logical reasoning in German elevates its underlying logic engine. It learns how to think, and that ability transfers across languages.
That is wild. It's not just translating. It's genuinely comprehending the logic beneath the language.
Exactly.
So we know how the architecture works, and we know exactly what it was fed to make it so smart. But where this digital brain was built is a huge part of why this paper is so important. Let's talk about European sovereignty, true open source, and ice-cold canals in Munich.
The physical reality of AI is something people often forget. When we talk about AI sovereignty in this context, we are talking about independence. Right now, most of the world relies on foundational models built by a handful of American tech giants running on massive hyperscale servers in the US or wherever they put them.
Yeah, mostly extra-European hyperscalers.
Right. But Soofi S was built end-to-end on the German industrial AI cloud in Munich using up to 512 NVIDIA B200 GPUs.
Which means it operates strictly under European data protection laws. Like a European hospital or law firm can use this infrastructure without their sensitive data ever leaving the continent or passing through a foreign tech monopoly service.
Exactly. And the physical infrastructure of this data center is just a marvel of engineering. Training an AI on 27 trillion tokens requires a massive amount of electricity, and consequently, it generates enough heat to melt the servers if you aren't careful.
Yeah, I mean, most data centers just blast industrial air conditioning, which uses even more power. How did they handle it in Munich?
This facility runs on 100% renewable energy. To cool those hundreds of GPUs, they actually pump in frigid water from Munich's famous Eisbach Canal.
Oh, wow, they just use the canal water.
Yeah. The water absorbs the massive heat from the AI training, but instead of just venting that hot water back into the river or the atmosphere, they pipe its waste heat directly into the local utility grid to warm the homes and offices of the surrounding Tucker Park district.
So you literally have this cutting-edge digital brain heating the physical city it was built in.
It's incredible.
The computation itself becomes part of the city's ecosystem. I absolutely love that.
Yeah.
But let's bring it back to the data itself. They claim this is a victory against open washing. What did they actually release to the public that the tech monopolies usually hide?
They release the receipts. To truly be open source, and they meet the strict Open Source Initiative 1.0 standard here, you have to show your work. The Soofi team released their intermediate training checkpoints, meaning you can see how the model's brain evolved over time. They released the complete hyperparameter logs of how they tuned the model. And most importantly, they released an exact per-source accounting for all 27 trillion tokens.
So if I want to know exactly how many math textbooks or coding forms went into this model, I can literally just look it up.
Yes. The only thing they couldn't legally release as raw, downloadable text was a specific commercial corpus of German newspapers called Genius due to licensing laws.
Oh, sure.
But even for that tiny fraction, it was just 1.3% of phase one, they still released the aggregate statistics and the exact mixture ratios. They hid nothing about the process.
So what does this all mean for you, the listener? Let's connect this physical, transparent reality back to the digital product. When you have a foundational model where you hold the exact receipt for every single token it was trained on, trust is no longer a leap of faith. It's verifiable. If a bank or a hospital uses Soofi S, they aren't guessing if the AI hallucinated based on some toxic hidden internet forum because they can audit the model's entire memory.
And if we connect this to the bigger picture, true open source is about the democratization of AI. For the last few years, the prevailing narrative has been that you need to be a trillion-dollar hyperscaler monopoly to build frontier-level AI. You need limitless money and limitless servers.
Right.
Soofi S proves you don't. It proves that if you have a clever, highly efficient architecture and meticulously curated data, a sovereign consortium can build a world-class model that rivals the giants.
It fundamentally shifts who gets to build the future of this technology. So to summarize the journey we've been on today, we started by looking at how Soofi S uses a hybrid Mamba-MoE architecture to slash inference costs.
Right.
We explored its meticulously crafted 27 trillion token bilingual diet that forced it to master deep reasoning in both German and English. And finally, we saw how a canal-cooled supercomputer in Munich proved that European sovereign AI is a deployed reality.
But as we wrap up, there is a fascinating limitation buried deep in the paper's benchmarks that we really shouldn't gloss over.
Oh.
Because Soofi S only activates 3 billion parameters at a time, its open domain factual recall is slightly lower than the massive, dense models.
By factual recall, you mean its ability to just memorize and regurgitate random trivia, like asking it for the capital of a tiny province, or the birth date of an obscure historical figure.
Precisely. It simply has a smaller raw storage capacity for encyclopedic facts compared to a model using 70 billion active parameters. And this raises an important question. Do we even want our AI models to memorize the entire encyclopedia anymore?
That is an interesting thought. I mean, we carry encyclopedias in our pockets.
Right. If models like Soofi S can reason brilliantly and they can process massive contexts instantly and cheaply, maybe the future of AI isn't about building a giant trivia brain.
Yeah.
Maybe it's about building a hyper-efficient reasoning engine that just looks up facts when it needs them. As you go about your day, think about how much energy we are wasting forcing AIs to memorize things when they could just be learning how to think.
Why build a massive skyscraper filled entirely with dusty filing cabinets when you could just build a really smart architect who knows how to use a library? That is a phenomenal point to end on. Thank you for joining us on this deep dive. We've gone from the blueprints to the finished structure, and it is abundantly clear that the landscape of OpenAI is changing faster than ever. Stay curious, and we will catch you next time.